Myself as Uma Shankar and my batchmate Bhaskaran are pursuing final year of BTech degree in the field of information technology in Vailtech High Tech, Dr. Rangarajan, Dr. Shakuntala Engineering College, and we are here to present a topic about designing an interest search model using the keyword from the clustered datasets. This slide carries the contents of the presentation in which we have discussed objectives existing, demerits of the existing system, proposed system, module list, description, work schedule, etc., conclusion and references. Objective. Main aim of the project is to show the customer interested products based on its various activities monitored in a social blog. Better performance is achieved by lowering the sampling rate of the tweets or posts to 3000 from 5000 over a fixed timeline. In the existing system, social blogs that holds millions of tweets or posts are always contains amount of noise and redundancy in large scale. Whenever a particular data about an event or a product or anything is to be mined, it results in millions of posts even though filtering is deployed. One of the major briefs that existed in the system is that purchasing history based recommendation has been so far introduced and there is no reverse mapping of that. Demerits of the existing system. More complex datasets cannot be handled, waiting time is increased, less accuracy, low data rate transmission, replication of requests due to inefficient offline clustering algorithm. Noisy datasets are also retrieved when mining important posts. Proposed system. In implementation, a user profile based purchase system is modeled. Twitter-like application is designed where users' likes are monitored along likes in the profile from the purchase website. Purchase portal will have two options like general purchase and profile based purchase. The developed purchasing website and the social blog will have a common database with the Hadoop server processing on the big data evolving from the blog. The big data are processed using an online clustering algorithm based on the time zone, say one cluster per month. The clustered tweets are then filtered for keywords to be matched for purchasing in the profile based purchase or personalized search. Architecture diagram concludes the entire working session of the project, in which profile account of both social blog and purchase portal is monitored and the collected data is processed by an Hadoop processing file system, and they are stored in a separate clusters, and then they are refined in a database, and from the database the keywords are filtered and the keywords which matches the products then are displayed in the purchasing portal. The block diagram also depicts the same explanation of the proposed system. User blog profile. User register his interest by posting his view on various products and general things. Social blogs maintain a record of user activity over the blog and maintains a separate record for each user. Activity involves posting, liking, etc. Purchase portal maintain a record of users' purchase history and display two options enabling recommended search and interest search. Hadoop server responsible for back-end monitoring of blog and purchase portal for identifying the interest of the user by observing a series of repeated activity. account database maintain the individual record of the user account and block in the database table format with necessary keys. Keyword filtering by the means of jQuery, keywords matching the products in the purchase portal with the post and likes of the user is retrieved. Purchase display the products matching the filtered keywords from the account database. Data flow diagram in which the user profile as well as the social blog and purchase blog through which likes and posts are collected, and then they are monitored for the post monitoring, and the monitored data is processed by Hadoop server by the means of Hadoop distributed file system and map reduce function. Periodical updation of the data is updated to the database, and the database is filtered for the keywords, and the filtered keywords is then made to match the products in the purchase portal, and then the interested products are displayed. Advantages of the proposed system: less time consumption over computation of online clustering algorithm. Accuracy is improved by mining subclusters for additional filter. Reliability over time frames. Data transmission rate is increased. Supports a wide range of data analysis tasks such as instant reports or historical survey. Modules: data insertion and update, construction of uptree, purchasing the item, discarding the unpromising item, finding the pattern from the tree. Module 1: data insertion and update. In the administrator side, we can add a particular data and also update the data. To each item, we can add and update the profit and quantity values for the product list. All inserted values and updated values are added to the database. The following use case diagram depicts the module 1. Module 2: construction of uptree. The construction of uptree can be efficiently performed with 2 scans of original database. First scan, transactions are finally computed, threshold value of single item is accumulated, the items in the transaction are sorted in the descending order of the transaction weight utility TWU. Second scan, transactions are inserted into the uptree. Module 2 use case diagram. Module 3: purchase the item. In the client side, user can enter all details. All inserted, also updated items are added into the product list. Then the user can select the wanted items and also add all items to the cart products with the count of each item. A warning message will display in the dialog box when the customer type the quantity above the constraint value mentioned in the database. All selected items are displayed in the cart product. Then the user can purchase the required items. Module 4: discarding the unpromising items. In threshold value mining, the user is required to type the minimum utility. Based on the value of the minimum utility, we can find out the promising item and unpromising item. Transactional weighted utility of an item set is the sum of the transaction utilities of all the transactions. It is a utility is less than the user specified minimum utility threshold. An item set is called low utility item set. To select interesting set of rules from set of all rules, constraints on several significance and interest can be used. The best known constraints are minimum threshold on support and confidence. Then the low utility item sets are discarded at the end of the transaction. This slide slide depicts the overall activity diagram of the module 3 and module 4. Module 5, finding the utility pattern from the utility pattern tree. Searching process for high utility item set mining is difficult because because a superset of a low utility item set may be a high utility item set. If transaction weighted utility is no less than a user specified minimum utility threshold, an item set is called high utility item set. Based on the TWU, we can find out promising items and unpromising item. Based on the threshold value, we can discard the unpromising item, then find out the promising items. Candidate item sets can be generated efficiently with only 2 scans of the database. Mining high utility item sets for the database refers to the discovery of item sets with high utility like profit. This slide depicts the overall sequence diagram of the proposed work. Hardware details. We have used processor Pentium 4 and RAM 512 MB with 80 gigabytes of hard disk, with front end running as NetBeans IDE and the back end containing MySQL database, Tomcat server and HDFS file system for monitoring purposes. Application. It is very useful in the field of interest surveying of people. It is useful for monitoring the interest of the user and predicting it to several other instances. It is deployed over the shopping portal to display the interested products of the user. This slide clarifies the work schedule of the entire project. Here we have attached some sample codings of the system. The following slides carry the screenshots of the completed project. Conclusion. We proposed a prototype which supports continuous tweet text stream summarization. It employs a tweet stream clustering algorithm to compress tweets into tweet clustering vectors and maintains them in an online fashion. For future work, a development of multi-topic version of the summarization algorithm in a distributed system, and also it is suggested to monitor more than one account per user to evaluate it on a more complex and complete and large scale datasets. These are the references we have collected for our project. Thank you.